Hello everyone, I'm Ms. Nilanjana Ghosh from Azanbian Cares International School. Today's video is for MOE Bilingual Grade 12 Chemistry. Topic: pH of strong and weak base. Chapter 8, Quantitative Equilibria. Learning objective for today's lesson 8.1g. Calculate the values of H plus and OH minus ions of strong and weak base. pH of strong base. Let us recall the definition of a strong base. A strong base is one which dissociates completely in water. Example: sodium hydroxide. Sodium hydroxide dissociates completely to form sodium ions and hydroxide ions. If the initial concentration of sodium hydroxide is 0.1 moles per decimeter cube, the concentration of hydroxide ions formed is also 0.1 moles per decimeter cube. In this reaction, we see that no H plus ions are formed because sodium hydroxide is a base. So how do we calculate the pH? Because the formula of pH is equal to minus log 10 H plus. To calculate the concentration of hydrogen ions, we use Kw, which is equal to the concentration of H plus ions times OH minus ions, which is equal to 1.0 into 10 to the power minus 14. So, substituting the concentration of OH minus ions in the formula, we can get the concentration of H plus ions. Another formula that we're going to use for this section is pH plus POH is equal to 14. Practice question. Example 1. Calculate the concentration of hydroxide ions in a solution of pH 1.23. pH provided is 1.23. So the concentration of hydrogen ion is equal to 10 to the power minus pH. Substituting the value of pH in the formula, we get the concentration of hydrogen ion is equal to 0.589 moles per decimeter cube. To find out the concentration of hydroxide ion, we take Kw divided by the concentration of hydrogen ions, which gives the concentration of hydroxide ion equal to 1.7 to 10 to the power minus 13 moles per decimeter cube. Example 2. Find the pH when POH is 4.19. From the formula, pH plus POH is equal to 14. POH according to the question is 4.19. So pH is equal to 14 minus 4.19 equal to 9.81. Example 3. Calculate the concentration of H plus ions and pH of 0.01 moles per decimeter cube of sodium hydroxide solution. Sodium hydroxide is a strong base, so it will dissociate completely to form sodium ions and OH minus ions. The initial concentration of sodium hydroxide is 0.01, so the concentration of OH minus will be also 0.01 moles per decimeter cube. Using the formula, H plus is equal to Kw divided by the concentration of OH minus ions. Substituting the value of OH minus ions into the formula, we get the concentration of H plus ion is equal to 1 into 10 to the power minus 12 moles per decimeter cube. To find the pH, we use the formula pH is equal to minus log 10 H plus. Substituting the value of hydrogen ions formed, we get the pH equal to 12. Example 4. Calculate the pH of 0.026 moles per decimeter cube of barium hydroxide. Barium hydroxide is a group 2 hydroxide which dissociates completely to form barium 2 plus ions and 2 moles of hydroxide ions. So, if the initial concentration of barium hydroxide is 0.026, the concentration of hydroxide ions formed will be 2 times 0.026, which is equal to 0.052 moles per decimeter cube. So the concentration of hydrogen ions will be equal to Kw divided by the concentration of OH minus, which is equal to 1.92 into 10 to the power minus 13 moles per decimeter cube. To find the pH, we substitute the concentration of hydrogen ions in the formula. So pH is equal to 12.72. Example 5. Calculate the concentration of a solution of NaOH which has a pH 11.20. pH given is 11.20. So from the pH we can calculate the concentration of hydrogen ions using the formula 10 to the power minus of pH. Substituting the value of pH, we get the concentration of hydrogen ion is equal to 6.31 into 10 to the power minus 12. To calculate the concentration of hydroxide ion, we use Kw divided by the concentration of H plus ion, which is equal to 1.58 into 10 to the power minus 3. Sodium hydroxide is a strong base, so the concentration of hydroxide ion is equal to the initial concentration of sodium hydroxide, which is equal to 1.58 into 10 to the power minus 3. pH of a weak base. Let us recall the definition of a weak base. Weak base is one which dissociates partially in water. Let us take an example of a weak base B. In water, it dissociates partially to form BH plus OH minus. The base dissociation constant Kb is equal to the concentration of the products divided by the concentration of the reactant, which is equal to concentration of BH plus times the concentration of OH minus divided by the concentration of B. Remember, water doesn't feature in the Kb expression because the concentration of water is constant. The concentration of OH minus is not equal to the initial concentration of the base because the dissociation is partial. So, the concentration of OH minus in a weak base is equal to square root of Kb times the concentration of the base. Another formula we are going to use is H plus. H plus is equal to Kw divided by OH minus, which is equal to 1 into 10 to the power minus 14 divided by the concentration of OH minus. Example 6. Find the pH of a solution of ammonia of 0. moles per decimeter cube. Kb provided is equal to 1.8 into 10 to the power minus 5. We need to know that whenever Kb is provided, that gives us an idea that the base is a weak base. So using the formula of OH minus for a weak base, which is equal to square root of Kb times the concentration of the base, substituting the value of Kb and concentration of B in the formula, we get the concentration of OH minus is equal to 1.34 into 10 to the power minus 5 moles per decimeter cube. To find the pH, we need the concentration of hydrogen ions. So using the formula Kw divided by the concentration of OH minus ions, the concentration of H plus is equal to 7.462 into 10 to the power minus 12. To get the pH, we substitute the concentration of hydrogen ions in the formula. We get pH is equal to 11.13. Example 7. Calculate Kb of 0.20 moles per decimeter cube of weak base of pH 11.30. pH given is 11.30. Using the formula, we can find out the concentration of hydrogen ions, which is equal to 10 to the power minus 11.30 equal to 5.01 into 10 to the power minus 12 moles per decimeter cube. To find out the concentration of OH minus ions, which is equal to Kw divided by the concentration of H plus ions, is equal to 2.0 into 10 to the power minus 3 moles per decimeter cube. We know the base is weak, so the concentration of OH minus ion is equal to square root of Kb times the concentration of the base. If we square both the sides, we get OH minus ion squared is equal to Kb times concentration of the base. So Kb is equal to OH minus ion squared divided by concentration of the base. Substituting the values in the formula, we get Kb is equal to 2 into 10 to the power minus 5 moles per decimeter cube. Thank you, everyone.